So hello everyone, welcome back to LeetCode Daily. In this particular video, we are discussing LeetCode daily problem of neighboring bitwise XOR. So in this problem, we have to given zero index array derived with length n and is derived by computing the bitwise XOR of adjacent values in a binary array. The binary array is original of the length of n, and we have to uh, for each index of I we have to given range of 0 to n minus 1, and these are two conditions we have to given, and after that we have given an array derived, and your task to determine whether there exists a valid binary array original that could have formed derived, and we have to return true if such array exists, or otherwise we have to return false. So now let's discuss this problem statement. So in this problem we have to given a derived array with their length n, and we have their binary array. The binary array is containing only 0 and 1, and the another thing is the derived array rule. These rules, like, one second, the rules we have to given here. First, if I is the last index, then the derived of I is equal to original of I XOR original of 0, and the same thing we have here. Otherwise we have I less than is equal to I less than n minus 1, then the derived of I is equal to derived of I XOR derived of I plus 1. So these things we have to given here, and our goal is to XOR is the determine if there exists a valid binary array original, such that we have to applying these two rules, and we have to interact with I is equal to n minus 1 form, and we have to calculate it value from first element of original matches itself. After completing the circular calculation, then we have their original is valid. So we have to find their original is valid, like we have given here 1 2 3. If we XOR with a b c, if we XOR with a XOR b and b XOR c, and same thing here for c XOR a, so these are our valid conditions. So after that, the key observation of this problem is we have XOR is reversible, like a XOR b is equal to c, and for a is equal to c XOR b. So this is our value of XOR is reversible, and the process forms a circular dependency because the first and the last elements of original interact due to rule of n I is equal to n minus 1 form, and it is calculated value for the first element of original matches, and itself after completing the circular, like whenever we have to calculate with these two and these two, we have their circular value of last to first, and these are our circular values we have to calculate. And the constraint we have given here, the constraint is delivered dot length has the exactly n element, and is 10 to the power 5. This 10 to the power 5 we have to go on up to these values, and so solution must be efficient on the complexity is O of n, and then derived are either 0 and 1s form, like this is a binary form. So now steps to solve this problem. first we have to assume with the first element is our original array, like either is 0 and it is 1, and the second we have to generate the rest of the original array using derived array. And the third thing is we have to check if the calculated last element satisfied the circular dependency. And the fourth thing, repeat both the process, like our assumptions for 0 and 1 for the first element, and the last one is if either assumption is work, then we have to return true, else we have to return false. So I hope you understand the problem statement. So now let's dry run this example test case. So in this test case we have given a derived array of 1 1 0. So the first we have their assumption, like here. So assume the original array is 0 0th index, and so now this is 0 and this is for 1. So now original of 1, we have like original of 1 is derived of 0 jor the original of 0. So the derived of 0 we have given here is 1, and we have to assume with 0. 1 jor 0 is always 1. So we have calculating here derived of 0 jor original of 0. So the derived of 0 we have to given here 1, the 1 1 0 we have to given here. So derived of 0 is 1 1, and so the original of we have to assuming, let's suppose this is 0, so 1 jor 0 is equal to 1. And another thing we have here original of 2 is derived of 1 jor original of 1. So the derived of 1 is 1, this one, and the original of 1, now we have their original of 1 is 1. So we have to assume all these original 1. Okay, so we have to get here 1 jor 1 is equal to 0. So here is 0. So same thing for the last one, we have to check with circular form. This is circular because we have here calculating with 1 jor 1 1 jor 0 and so on. So the derived of 2 jor original of 0. So the original of 0, let's suppose the derived of 0 we have to given 0, and the original of 0 is 0. So that's why we have to get here 0 jor 0 is equal to 0. So here we have given the condition of this is true, because we have both assumptions work, like we have their answer, we have worked with their answers. So now we have to discuss one more thing, like for another approach, like visualization form. Let's suppose these are our steps. Okay, and the action, which action we have to perform, and after the value. Now the initialize, we have there int answer is equal to 0, so the action is answer is equal to 0, so the value is equal to 0. So this is our init condition. And now let's this one, we have given here the arrays 1 1 and 0. So now first we have there add is equal to 1, and the answer is equal to answer plus is equal to 1, so the answer is 1. And same thing for add is equal to same 1, answer plus is equal to 1, so the increment the value 2, and add 0, answer plus is equal to 0, so the 2 plus 0 is 2. And so now check with odd even, check odd oblique even. So now if we have to check with answer answer and 1, so if it is true then we have to return true. So here we have getting here is a which condition, this is even condition, so that's why we have to true condition, true we have to return. So one more thing for false case, for understand how it actually work, so this one 1 0 for same approach like this one, for answer is equal to 0 first, and we have given 1 comma 0, so the steps and the action and the value. And now first init condition answer is equal to 0 is 0, and so add 1, answer plus is equal to 1, so this is 1, and add 0, answer plus is equal to 0, 1 plus 0 is 0, so we have to check with this condition answer and 1, so it is false for this one, so it returns false because this is odd, and so now this is false. So now let's discuss this code, this one code, for how we implement this. And one second. So this one, first we have to initialize with their answer for calculate their cumulative JOR of all element with delivered array. And after this loop we have to check with their delivered of I, and we have directly check with their JOR sum. This is our JOR sum, we have to check with their element which is delivered is odd or even using answer and 1, and answer and 1 will evaluate to 1 if the sum is odd, and 0 if the sum is even. And after this we have to return a false when 0, and true when return when we have to get 1. So after this, so after that we have their mathematical insights, like the JOR follow specific rule, a JOR a is equal to 0 and a JOR 0 is equal to a. So these are our properties we have to follow up here. So now time complexity of this code is, so the time complexity of this code is O of n, because only single loop we have to run, and the space complexity is O of 1. So I hope you understand the logic and their implementation part for better understanding. So thank you everyone, thank you so much.